John, Dr. Yvette obtained her PhD and MS in mathematics in DLSU University under DOST SF scholarships. Dr. Lim received the 2003 NASD Outstanding Scientific Paper Award for her article, The Bandwidth of the Cartesian Product of a Double Star and a Path, published in the Manila Journal of Science. She has actively served in the Mathematical Society of the Philippines as a board member from 2004 to 2015. Her research interests are in the areas of graph theory and game theory. Without further ado, let us welcome Dr. Yvette F. Lim.
Thank you, Leah, for that introduction. Good morning, everyone.
Good morning.
So, I am here to present how I conducted my classes on linear programming. Okay? The talk is entitled Linear Optimization, a Graphical Approach. And okay, for the abstract that you could find in your program, it says there that linear programming is concerned with the optimization of a linear function. So we will only be concerned with linear functions for linear programming. So for a typical example, if you would like to find the production level that will produce the maximum profit or the minimum cost, you may use linear programming as long as all the functions that you have are there are several methods to solve linear programming problems. However, for the math in the modern world, we will only be concerned with solving linear programming problems using graphs. This is the first slide that I use in my classes. I had 4 classes last term. Okay, so this is how I conducted my class. So first, I introduced the problem. The problem is linear programming model. So I present this to my students. Find the maximum value of z equals 2x plus 3y subject to the following constraints. Of course, most of them will not understand the problem at once. Okay? So after that, I introduce this study, which gives them an idea of what linear programming is. Okay? Because from the words linear programming, the students have a concept that they would be dealing with C++, Java. So I opted to give them this description of linear programming. That it is not referring to the programming that they had today. So the term was introduced in the 1940s, where programming was synonymous with scheduling or planning. Okay? And it is a subcategory of mathematical programming. Since I have mentioned here mathematical programming, on the next slide, I also give them a description of a mathematical programming. Okay? It is a term which represents the maximization or minimization of objective functions. And this minimization or maximization is done subject to constraints. Now, since I mentioned the objective function, I define here what an objective function is. So, an objective function is a function of one or more variables that one is interested in. in either maximizing in terms of profit or sales and minimizing in terms of costs. Okay, and then next, I define constraints. The constraints are equalities or inequalities and describe restrictions involved with the objective function. Okay? And then, I showed here the problem again. Okay? Wherein, I give them the part which gives the objective function and the constraints. Okay? So, I did not mention that this is called a linear programming model. I just say that this is the problem that we are to solve at the end of the course or at the end of the lesson. Okay? And then, to solve this, I opted to recall the x-intercept and the y-intercept because we will be using graphs. And to graph, instead of using any other method, I use the x-intercept and y-intercept and connect them with the line. So, at this point, the students would already relate. They know what x-intercepts are, they know what y-intercepts are. So, although there are some, because my students are from liberal arts, they're not really interested in math. So, some really do not know x-intercepts and y-intercepts at that point. Until you show this, oh, that's what x-intercept is, and that's what y-intercept. Okay, and then after that, before introducing how to graph inequalities, we first sketch the graph of a line. Okay? And then, for the introduction for sketching the graphs of inequalities, I choose this x minus 2y plus 4, which is one of the part of the constraints for the problem. Okay? And then to sketch the graph, I use obviously the x-intercept and the y-intercept. Okay? So I ask them, without showing how to find the x and the y-intercept, by just the definition. By just the definition of the y-intercept and the x-intercept, they were able to compute. Not all of them, but most of them. So for the x-intercept, obviously, it is 4. And for the y-intercept, it is negative 2. Okay? And then, basically, I do not show this graph first. I use the blackboard to... So I use the board and sketch the line 1, 2, 3, 4, okay, 1, 2. And then I told them that it's just connecting the dots. And when you say connecting the dots, I would also joke that it was just like your pre-elementary, you just have to connect the dots. Okay. But be sure that the line is straight. So you do like that in class. Okay, and then after that, I show this. Okay, and then given this graph, how do we graph the inequality x minus 2y is less than or equal to 4? I use the test point. I told them that they may use any point, okay, that they want, as long as if the inequality is satisfied, the test point that they will use will be part of the region, and if it is not, it will be the other side of the line. What happened? Sorry. Yeah. Okay. Okay, so as I was saying, I used the test point. And I told them that the easiest point to use are that the easiest point in the main use is the origin, which is 0, 0. So obviously, if you will substitute 0, 0 to the inequality, this is satisfied. So therefore, the region is the region which contains the point 0, 0. That's it. So this is only for the inequality x minus 2y less than or equal. Now, after that, I told them to find the solution to the system of inequalities graphically. So we already had the x minus 2y less than or equal to 4. They would just draw the 2x plus y less than or equal to 18 and y less than 10. So, using the board, I have to draw the line 2x plus y equals 18 first before drawing the region for 2x plus y less than or equal to 18. So for 2x plus y less than or equal to 18, the x-intercept is 9. Okay, medyo mataas. Okay, and then for this second inequality, if you use the test point 0, 0, it will also be satisfied. So I do not really shape the region. I just show them that the arrows are going to that side. So this arrow should also go to that side. Or otherwise, it will be very difficult for them to visualize, which actually is the intersection of all the regions. And then for the last one, y is less than or equal to 10. Using also the test point, and then finding the intersection, the students will be able to visualize that the solution is actually that region. Okay? Now, some of them, from their high school, they already took this up. But not all of them really knows how to graph or to solve a system of inequalities. So we really have to teach them how to solve a system of inequalities. After that, I would, as part of our lessons, okay, after that, we have some exercises for firming up. I got this from some sources. Okay, so solve the following system of linear inequalities. And the students, usually, you will not finish that in one meeting, that part. So this will be some sort of an assignment. Okay, and then they have to submit the solution the next meeting. Okay. Somehow, most of the students got the answers right after this discussion. After that, if you will notice, we just added the non-negativity constraints. Okay? So, after adding the non-negativity constraints, obviously, the solution will just be on the first quadrant. And then, you have to tell them that this is actually called the feasible region for the solution of your problem. So after that, so this is the solution. Again, I show them the problem presented at the start of the class or at the start of the meeting. And then we now have the feasible region. Now, what is different here from the solution is that we indicated the corner points of your feasible region. Okay? And then you ask them to solve for the coordinates of these corner points. Okay? Again, some students could easily do that. Okay? Especially for this. Especially for the origins. And for this corner point, you have to recall that this is just the intersection of these two lines. So they have to solve them using solving a system of linear equations. And this is easy because you have their y equals 10. So they just have to substitute 10 to 2x plus y equals 8. Okay? And then find the intersection of these two lines. Okay? And then this is easy because this is just the x-intercept of x minus 2y equals 4. Okay. After that, after they computed the intersections, okay, so you have to consider these 5 corner points to solve the problem. Okay. We make it easy, we just substitute the corner points, the coordinates of the corner points to the objective function. And then they have, since the problem is to find the maximum, they will just have to choose which one is the maximum from 0, 8, 20 to 30. So they know that the solution to the problem is you will have the maximum of z equals 2x plus 3y given the constraints. If your x is equal to 4 and your y equals 10, which gives you a value of z which is equal to 38. Okay, now, before I show this step to solve the linear programming problem, they know already. And I was really so happy because, okay, how do you solve the linear programming problem was the first step. Okay, they would, after all the lessons, all the discussions, they would be the first one to say, okay, you have to graph and determine the physical region. The next step, you have to find the coordinates of the corner points. And then the third step, you just have to substitute. So, I'll show this just to remind them, just in case they will forget. And then, I give an application wherein we already have a word problem. Okay, so given this word problem, but actually, for quizzes, I do not give word problems because it will be very difficult for them to translate this word problem into the linear programming model. So this would just be deepening or firming up or an assignment task, okay, an extra task. So given this word problem, okay, the liquid portion of a diet is to provide at least 300 calories, 36 units of vitamin A, 9 units of vitamin C daily. Now, a cup of dietary drink X provides 60 calories, 12 units of vitamin A, and 10 units of vitamin C. A cup of dietary drink Y provides 60 calories, 6 units of vitamin A, and 30 units of vitamin C. Now, suppose the dietary drink X costs 12 pesos per cup, and drink Y costs 15 pesos per cup. How many cups of each drink should be consumed each day to minimize the cost and still meet the stated daily requirements? Now, the application that I chose is minimization because I already have a maximization for the problem I presented at the start. Okay? So, you have to translate that word problem to the linear programming model, which is this one. You have to find the minimum cost C equals 12x plus 51 subject to this constraint. Okay, so I would go from this slide to that slide and this slide to that slide. So I will tell them, so where did you get the 60x plus 60y is greater than or equal to 300? So they would really relate the word problem to the model. Okay? So now we have another problem. Now, in this case, we want to minimize the cost. Okay? So I asked them to graph manually. So they were able to do so. And they were also able to find the solution to the problem without showing the solution to them at this point. Kaya na nila. Because the process is really very easy to follow. Note that for most of you who knows about the gradient, the sliding, the level curves, we do not use that because it will confuse the students. Okay? So, you just substitute the values of the corner points. If it's maximization, you just choose the maximum. If it's minimization, you choose the minimum. As simple as that. But you have to be very careful in discussing this because we cannot find the maximum for this problem because we have an unbounded region. Okay? So for this problem, we have 4 corner points. Okay? And obviously, since they were the one who found the visible region, they would know which line represents which. So they would know how to find the intersection. Which are those points? Okay. Still the 6. Okay, 1, 4, 3, 2, and 9, 0. So basically, when you substitute that, okay, the minimum cost would be at C, at the point 3, 2, which gives you 66. Okay, now again, we give them several problems to work on. So this one is the model itself. Another one, the model itself. So I have here a maximum and a minimum. Okay? Now for the deepening, I again give a word problem, which is product mix lang, yung simple na. Okay. So, this is actually an assignment for them. They will not do it in class. Now, for exploring, okay, from the given problem at the start, suppose there is an additional constraint x is less than or equal to 5. You would ask the students, what will happen? Okay? Is there a change in the physical region? Is the optimal solution the same? Or is there a new optimal solution? Due to the limited time constraint, they were not able to do this. Okay? Parang ang dali, ano? Bilis-bilis. Pero pagka diniscuss nyo sa kanila, medyo mabagal sila wait, there are fast learners, but we have to admit there are slow learners. So for this one, I will just show you the graph. For our class, we have a lab component. So, I use personally the Graphical because this is the one installed in most of our labs here. So this is the one I just sketched here on the board. Now, sumubra yung laki mo. This line here, okay, that's x plus 5. So, if you will notice, there will be really a change in the physical feature. So, our optimal solution before, okay, would only have 5, for the corner points of our problem before, we would only have 5 corner points. Now we will have 6. So they have to find the coordinates of this, which is actually 5, 8, and this one is 5 and 0.5. And then they have to substitute it with the original problem, and then they will be able to answer if the optimal solution is the same or not. So that's it for the exploring. Actually, hanggang dyan lang yung lesson natin. No? And then for the assignment, you would also give the students, okay, the responsibility to check if there are other methods to solve a linear program. And you know that there are several methods to solve the linear program. And then, we also ask them to grab their thoughts. Especially my students are from liberal arts. They really like this. Now, these are just guide questions. Linear programming is blank. Mathematical programming is blank. An objective function is blank. Constraints are to solve a linear programming problem means, for me, linear programming is useful since blank. I find this topic blank. Okay. A few students will just give you a blank, filling these lines up. But there are several students who will not do that, but rather they will do like this. See? This is a sample blog of one of my students. Okay? See how long her blog is.